All right, we're going to look at the last major topic, solving rational equations. The only thing after this is word problems, but it uses all the same concepts. So rational equations, what we've been working with so far has been just stuff like this, where it's just terms, basically fractions with variables in the denominator. But now what we're going to do is we're going to throw in that equals sign. Whenever we have stuff like equals sign, right, 3x equals 5, we're trying to figure out what x is equal to. So we're trying to isolate. That's our goal when we have questions like this. Just like all the other times when we were working on it, we're going to factor and simplify first. If there's anything we can factor and simplify. In this one, there isn't. There's nothing I can do. Again, some people might be thinking about like, oh, I'm going to cross multiply stuff like, no, okay? Leave that, don't do that. You only do that when you're multiplying. What we are going to try and do is get rid of the denominators. I need to point out like a key difference in what we're doing here because I think a lot of students get hung up on it. So in the previous one, what we were doing was if you had like something like 3 over x plus 1 over x plus 1, we were thinking, okay, we want these denominators to be the same, x and x plus 1. So what we did was we multiplied by essentially 1. We multiplied by like x over x and x plus 1 over x plus 1. The reason we did this was so the denominators would be the same. The reason we had to do it this way was because it was a rational expression. There's no equal signs here. But as you probably remember from working with equal signs, like in grade 9 and stuff, there's a special trick we can use because of the fact that it's an equation. If I had like x over 3 equals 10, I can just multiply both sides by 3, actual 3, not 3 over 3, none of that stuff, actually 3. And this will cancel out and it will become something like x equals 30. So we're going to do the same idea here. We're going to multiply just by what the denominator is to get rid of it. So I'm going to multiply both sides by just 2x. Not 2x over 2x, not 1. You could do that, but I don't need to because it just makes it so much easier this way. When I multiply by 2x on both sides, it's right up here so it makes it a little clearer. 2x, 2x. Okay? This denominator is going to cancel out. So now I'm just left with 3. Great, I have one less denominator to worry about. Now what I'm going to multiply by is this other denominator, x plus 1 times x plus 1 times x plus 1. Okay, so now again, this is going to cancel out. I'm just going to be left with 2x on this side. I have to do distributive property, don't forget that, 3x plus 3. So now when I'm simplifying, and at this point, grade 9s can solve this question. I'm going to rearrange, so move this here, move this here. I get x is equal to negative 3, and I'm done. Okay, the last step, as always, NPVs. So x cannot equal. When I look back at the start, it couldn't be 0 or it couldn't be negative 1. Nothing changed throughout, so that's my answer. Good. Okay, these questions I actually think are easier because you just multiply to get rid of the denominators. Let's do a little bit of a tougher question over here. Okay, it's going to be the same process. The first thing I want to do is factor and simplify anything. So looking at this denominator I think can be factored. So I'm going to do that just so it's easier to see. K plus 6 equals 1 over k. All right. You can do more than, you know how over here we did times 2 first and then times x plus 1? You could do that at the same time. If you're going to make mistakes, obviously you shouldn't. Let's try doing it at the same time. So I see I'm going to have to multiply by k to get rid of those, and k plus 6. So I'm going to multiply everything by k and k plus 6. So in this one, the k will just cancel out, and it'll be 6 times k plus 6. So it'll be 6 k plus 6 minus. In this one, the denominators get canceled out, and there's nothing left, so it's just minus 1. On this side, it's 1 times k plus 6. So we got that. If you had done this in 2 steps, it still would have worked, but I'm done now. Now I just need to simplify. So I'm going to expand out. It was ugly, expand. 6k plus 36 minus 1. I'll move these to the other side while I'm at it. So I get minus k minus 6 equals 0. What do we get? 5k minus 29, plus 29 equals 0. 5k equals negative 29. K equals negative 29 over 5. Okay, well, I think I made a mistake. No, that looks right. Yeah, ugly, but yeah, that's right. So that was it. And now we have to do NPVs. K cannot equal 0, obviously, and -6 when I look back at those originals in the question. And that's it. Yeah. So when you multiply these out to get rid of the denominators, just don't forget that, like, if there is no, for example, this one, we have to multiply and the numerator is going to change. But in this middle term, it actually stayed the same because the denominator was the same as what we were multiplying by. There's one more topic we need to talk about. It's extraneous roots. So this is another example right here. Sorry, it's kind of blurry. This was the original question, and then we solved it. So when we multiplied everything out, it simplified to this. And then when we isolated x, we found this. Let's just do the NPVs because they didn't do it actually. So let's see. X cannot equal. When we look at the original question, can't be 2 or -2. So let's write that. 2 or -2. But this is where you got to be careful. When we look, our answer was 2, but our NPV says x can't be 2. This is what's called as an extraneous root. This is where you get an answer that cannot exist. It does not exist based on the way the question was designed. So even though it looks like the answer is 2, you have to say, like, you have to write the NPVs and you say, like, no solution. And you put a little tearing face. Because the value you got was actually not possible. If it asks you for a reason, you can say the root is extraneous. This means like extra, unneeded, whatever. But yeah, it's a root that is actually not possible based on the situation. And that's it.